morning, everybody. Thank you for joining. What we're going to do here today is this is probably going to be the most interesting discussion on phosphorus you've ever listened to in your life. So thank you for joining here this morning. My name is Brian Reinecke. I'm the Director of Agronomy with Phospholutions. I'm going to talk to you a little bit today about advancements in phosphorus science and how it relates to improved technology and innovation. After all, we're here at Tech Hub Live today, where we're learning about more and more innovative ways of doing things to become more efficient in what we're doing. We're going to be discussing a more modern day approach to phosphorus for fertility and advancements in science and technology. As we go through our discussion here today, I'm going to outline some things about what is currently happening with phosphorus, and I'm going to introduce you to a new product called Rhizosorb by Phospholutions. Since the 1960s, a lot of things have changed in farming, haven't they? Advancements, we continue to advance in science and technology, innovations through a lot of equipment, through a lot of helping to improve our management styles, the way we do things in our crop production aspects today. A lot of things have changed, like seed, genetics, I mentioned equipment, fertilizers, crop protection, just to name a few. We no longer drive our grandfather's pickup around the farm. Now, the pickup like this might still be on the farm, but it's usually for running from field to field, maybe changing or fixing pivots. But we have all improved what we're doing by advancing our technology through innovation and efficiency. Things like this that we do today, we pay a lot of attention to from a machinery point of view, but what do we do when it comes to fertility? Less efficient practices are being put out to pasture in favor of greater efficiency with less effort and less time. So those are the things that we're all used to seeing today. I don't see any more of the little tractors in the field anymore just because the equipment's too small, horsepower is not enough. So that goes to the mindset of how we are doing things that were once commonplace have now been replaced by precision equipment and variable rate technology to improve our yields, our quality, and our field performance. Here's where I'm going with this. We do all these things in science and technology, yet most of us are still applying the same old phosphate technology that was produced or came out in the early 1960s. So we're talking 65 years ago. I know I'm not that old. Most of you in here are way younger than I am. So there's a lot of things that have happened in our industry to improve efficiencies, yet where have the efficiency improvements come for phosphorus like MAP and DAP? So Phospholutions would like to introduce to Tech Hub Live here today the newest and next generation in phosphate fertilizer called Rhizosorb 8390. And we'll get into some of the discussions as to what it is, why it's important, and why you should consider taking a look at it in your farming operations or at your retail outlets with your customer base that you're working with. Before we do that, let's talk about some things on where to begin. What are your overall plans and objectives for your fertilizer systems, recommendations, and how do you approach that? How do you fertilize? What do you like about the way you fertilize? What don't you like about it? And what might you be willing to take a look at to change as we improve the innovative practices of what we're doing with crop production today to more align ourselves with those top end yield potentials that come in corn and soybeans and every other crop that we are growing. I'd like you to also consider this. How do you define soil fertility? What are some of your biggest challenges either in your own farming operations or with your clients and customers that you're working with in the field? How would you define that? And what are the biggest challenges that you are faced when trying to answer this question? Throughout my career experience, I have spent a lot of time thinking about soil fertility and plant nutrition. And I asked you that question to give you the consideration of, are there similarities or are they different? Are they the same or are they different? The way that I have looked at it through my experience is that soil fertility and plant nutrition are not the same, but you cannot have one without the other. In most cases, our soil systems are not super efficient, yet when we are making recommendations and looking at our crops and what we need for fertility, especially phosphorus, our soils will only do as good as they can do given the limitations that they have. So what does that mean? The soil can only give up what it can give up, meaning chemistry takes over and things within our soil system begin to affect the availability and the efficiency of phosphorus. Things like pH, organic matter, base saturation, and moisture and organic matter. I said organic matter, but So how do we drive greater plant nutrition? What are the processes that we are involved in or should be involved in to take a look at? How do we build that bridge? We need to build that bridge that connects plant nutrition with the essence of plant demand for crop nutrients. We cannot get it all out of the soil the way our soils are designed today. So what we're going to talk about as a potential improvement for phosphorus use efficiency and phosphorus fertilizer is Rhizosorb as we continue this talk. So bridging the gap, where do we start? We need to start with doing extensive soil testing, which many of you are doing that, and we're becoming much more prescriptive even in the innovation of how we are taking a look at taking soil samples and analyzing those reports to develop recommendations. Our crops grow faster than our soil's ability to keep up with that pace of growth, to mineralize nutrients and apply them to the crop. So through improved effectiveness and efficiencies, we're at the point where in order to achieve the necessary top-end yields, we have to be mindful of the innovation that takes place or the innovation systems that are available to us today and going to continue on to the future in looking at improved soil fertility management and crop use. So as we take a look at some of the agronomic challenges that we're faced with, phosphorus gets tied up in the soil very, very quickly. I think many of you, especially that are in the field and working with agronomics, it gets very tied up in the soil very, very quickly because of the chemical action like pH, for example. We're going to talk a little bit more specifically about pH as we go through here. Once this phosphorus is fixed in the soil, it becomes really difficult to get it unbound from those clay particles because of pH and some of the other considerations that I mentioned in order to move it from the fixed pool to the active pool and then the soluble pool. How many of you know that according to land-grant university science and research for at least the last 20 years, how efficient our phosphorus materials are? Think about that and I'll tell you the answer. A lot of our phosphorus that we apply today as MAP or DAP fertilizers is at best only 10 to 30% efficient. So you take the rates of whatever you are applying and then use that factor in P2O5 calculations to actually learn how to understand what our efficiency factors are and then start to calculate what the true cost of your phosphate is. Phosphorus is either going to be mineralized or solubilized within our soil structure system. And the ultimate objective of everything that we do in crop production is to drive nutrition to the crop in order for us to maximize our yield opportunity. So among the many phosphorus management challenges that we have, some of the misconceptions as you see here are broadcasting all of our fall peak, or for that matter even spring phosphate applications, thinking that we'll get a little bit out of it for this year and it'll be stored for future use. To some point that's true, but that's not necessarily the way soil chemistry works because of the imbalances in our soil and the actions that take place from a chemistry point of view that dramatically affect phosphate. Our current system of phosphate understanding and the way that we approach it is that soil testing, our framework for soil testing, leads us to an over-application of phosphate because the efficiency factors are so low. So we are constantly adding more phosphorus to the soil and other things that I will get into that are providing some barriers to maximizing our efficiency because the soil does not have the chemistry ability to mineralize it fast enough to keep up with the pace of growth of our crops. And to demonstrate that a little bit, we've conducted some MAP release studies, and as you see here on the lower left of the corner, you have the x-axis is a number of days, the y-axis is phosphorus release as a percentage of the material. I mentioned earlier on that MAP releases very, very quickly, solubilizes in the soil, and reacts with the soil very quickly to become tied up, and very little of it is available for use going forward through the rest of the season. And so you notice here, by the time you get out to 30 to 40 days after application, and I always put this qualifier in to say, after application and soil conditions conducive to mineralization and release of the fertilizer, you're going to have as much as 95 to 100% of the phosphorus material that you apply to the field tied up in the soil and not active and available to the crop. More recently, there's been studies going on at various land-grant universities. This is some beginnings of some studies by Dr. Chad Penn, a soil scientist out of the National Soil Erosion Research Lab, where he's been doing phosphate studies on luxury consumption to actually chart out when the plant can no longer accept or take phosphorus into the plant and contribute it to yield. And when you go past that point, looking at the ideal P availability of 0.6 of a gram per plant, you can multiply that out over your plant population to come up with your application rate per acre. You can see that you peak out as phosphorus contribution to yield, and anything left after that is just going to go to biomass. It's going to make a nicer, prettier plant, but it's not going to contribute to your yield objectives. So that is called luxury consumption. There's a whole lot more behind this that I don't have time to do today. We'd be glad to talk with you about it over at our booth. So some of the issues that we're dealing with in fertilizer management is current phosphorus management is more or less a theoretical extraction based on a correlation of extraction of nutrients, not based upon plant needs. Just because we have XY levels of phosphorus in our soil system and our soil analysis test reports does not mean that that is all going to be 100% converted and mineralized to feed the crop through the season. Over application is a huge thing, as we are learning more and more because of the algal bloom issues and other water quality concerns that are showing up around the globe that are becoming more of a commonplace conversation. Phosphorus is over applied with the idea that it's going to be banked for future use. Yes, to a point, you are going to get some use, but the rate of release over time in order to get that phosphorus you applied this year to the future crops can take as much as 10 years. So it's not a really efficient system. So how do we improve phosphorus in our management system? Learn how to increase plant uptake, reducing soil tie-up, and improving the efficiency of phosphorus in our soil systems, and this is where Rhizosorb is going to play a big piece of that game. So to summarize our fertilizer challenges, the agronomics, only 10 to 30% of what we are currently using is actually available to the crop in any one given season. The economics, I don't need to talk a lot about the economics here. Most of us all know where phosphate prices are today. Very expensive, and growers are being squeezed harder and harder to figure out more efficient ways to address their plant nutritional needs in order to get to where they're going so they can remain profitable. And then the sustainability piece. There are finite reserves around the globe that are dwindling fast, according to a lot of the research and science and some of the news reports that are coming out. It's a non-renewable resource, so we have to get better at identifying our systems of phosphorus use efficiency and crop improvement so that we can sustain those reserves for a much longer period of time, as well as reduce the amount of phosphorus that goes into our rivers, lakes, and streams. So here we go with Rhizosorb. What is Rhizosorb? Rhizosorb is a patented proprietary blend of naturally occurring soil minerals that are embedded into the phosphorus production plan or system at the time of manufacturing. It's a fully homogenized, ready replacement for MAP or DAP, and I'll go into this, some of the reasons why I think you can fully replace MAP or DAP as you're using today in favor of Rhizosorb. And what Rhizosorb does is it actually mimics a natural soil chemistry for action within that soil to the signals that the plant sends out in order to take a unit of phosphorus out of the soil and then be replaced and held in that soil suspension because of the minerals that are part of the active ingredient. So as a plant takes up a unit of phosphorus, the soil will replace a unit of phosphorus, and that cycle continues throughout the growing season. So I will also say what Rhizosorb is not. Rhizosorb is not a biological material. Okay, so it's not a biological, it is more based on the chemical gradient that functions within the soil through natural high concentration to low concentration through natural diffusion. So phosphorus, improved phosphorus uptake. What Rhizosorb does is it slows the release of phosphorus into the soil system over a period of time through the growing season. It's not necessarily based on moisture as much as and being degraded as much as phosphorus is throughout the time of from the time of application to plant need. This allows us as growers and retailers and consultants that are making recommendations for phosphorus to be able to use less P2O5 to achieve the same or better result in your production plants through a tissue analysis that translates to yield. And that's, at the end of the day, that's what we growers are most interested in, is how to become more efficient and make more money while reducing our costs. So when we take a look specifically at Rhizosorb's performance against or in comparison to MAP and DAP, you can see very consistently that a reduced rate of P2O5 against any grower standard practice, wherever you are at in the country and whatever P levels that you are using in your crop production, you can use significantly less. Our calculation in our corn and soybean model is actually based on a 50% P2O5 reduction to achieve the same results as MAP or DAP. I mentioned pH early on, and what you see here is a pH range on the bottom against a biomass measurement in terms of grams. So Rhizosorb, it actually increases plant growth across a wide variety of pH range. We know that chemically speaking, from a chemistry point of view, that phosphorus is dramatically affected by pH, and the very narrow range of phosphorus acceptability or the processability mineralization of phosphorus actually runs from about a 6.2 to a 6.8. How many of us are farming in soils that are that consistent over everything we do? So we need to be taking a look at how we can improve plant use efficiency by utilizing Rhizosorb, and with the ability to keep that in soil solution for a longer period of time across a pH range. So I showed you this a minute ago relative to MAP. Here is the release curve for Rhizosorb. It falls under the same general principles. However, because of the mineral that is part of the active ingredient, we are able to move the dissolution form to a longer period of time throughout the season. I mentioned early on 30 to 40 days after application, our MAP sources are tied up in the soil. We can extend that availability in soil solution out to 60, 70, or 80 days. Why is that important? What's happening right now across the Corn Belt? All of our corn, beans, everything else are going into reproductive stages, and that is when plant demand is the highest, when we get past that 40, 50-day use range, and Rhizosorb will still be able to maintain its solubility and solutionability for natural plant uptake through a longer period of the season. We are now backed by more than 30 years of research. Where the Rhizosorb concept came from, it was actually developed back in 1991 by Dr. Jonathan Lynch at Penn State University, world-renowned scientist on phosphate and root development formation. Feel free to look him up. We have an R&D staff with more than 400 lab assays, greenhouse work, small plot replicated research, and as well as in the last 3 to 4 years, we have done extensive work at scale in full field environments, because the variability across the field is much greater than it is in a small plot situation. So we continue to quantify this going across the year over year. So what you're looking at on the screen here is research studies from Penn State University, year over year, phosphorus yield results, corresponding tissue results. I'll get to the right side of the slide in a second, but you can see in 19, 20, 21, and 22, year over year, our phosphorus tissue test measurements are consistently the same, statistically the same, if not slightly better year over year, meaning that we are using less P2O5, getting it in, moving it into the plant, and transferring out into yield. And you can see the yield results, consistent yield results equaling to or being better than a grower standard practice. Very important to see. Now, the other part of these studies is taking a look at zero MAP applied, 50% of a grower standard rate, and then 100% rate. We all know and have proven out through many studies and things that we have done agronomically in the field that you apply no MAP against a standard rate, you most generally will see a negative yield impact when you do that. At a 50% MAP rate, to grower standard, you can still see that there's a bit of a yield drag. When we have done this in comparison with Rhizosorb, we're equal to, in year-over-year studies, the grower standard practice with a 50% P2O5 reduction. To demonstrate this a little bit in proven yield, you can see our footprint over the past few years. We have done this across a wide variety of soil types, weather patterns, cultural practice, and freeze-thaw, drought, heat, those types of things. And 140 trial locations over 16 states with an average win rate of 83%. I'll highlight corn because we're sitting here in Des Moines, Iowa today. We have seen a 93% success rate when using Rhizosorb over a grower standard practice. Over those 31 sites in 2022 yielding about a 5 bushel advantage. And the compilation of results year over year from a bushel perspective in field situations, this is what we have returned. To break it down a little bit, in our corn trials, 62 trial sites resulting in 85% success rate, equaling about a 2.3 bushel per acre yield advantage using less P2O5. In soybeans, similar situation, 21 sites, 76% success rate with about a 1.6 bushel advantage. So when we get down to the brass tacks of what Rhizosorb really is, it's a homogenized dry fertilizer ready to use, comes to your retail locations and delivered to your growers and whatever other situations that your retailers might be using to help you improve phosphorus efficiency or overall general plant nutritional efficiencies. Rhizosorb is used in the exact same way with the same handling characteristics as MAP. And here's the benefit, one of the many benefits that Rhizosorb brings to the table. We have a 38% lower salt index than we would have relative to the calculations on MAP. The granule size is very consistent, the bulk density is very consistent, so it's just a replacement for your MAP for an improved efficiency, enhanced efficiency fertilizer product. And why is that important for salt index is because any of you that are strip tillers, minimum till or no till, where you might be concerned with salt layers or stratification, you can now be sure that you are applying less salt to help improve the efficiency of your phosphorus, but also help to improve some of the potential toxic effects that you might be experiencing with continued use of high rates of traditional MAP or DAP. So grower economics, when we start talking about some easy numbers here, if you were going to apply 100 pounds per acre of MAP, our recommendation for Rhizosorb is going to be 66 pounds on a comparative study to address everything that we've previously talked about in yield and plant use efficiency and uptake. And so on the front end, we position Rhizosorb as a cost per acre savings to the growers, combined with the backside benefit and the end of season benefit of better than average yield returns based upon the statistics of what we have done over the past 6 to 10 years. And if you're interested, you can scan that QR code and get some more information or come talk to us at our booth. One of the things that we are also offering as a new advanced innovative phosphate fertilizer material in the marketplace today is a grower guarantee. We've done extensive work. We've basically built the airplane. Now we're ready to take off. We introduced Rhizosorb into the market in 2023. We have it in place around many states in the country here in 2024. And we offer basically a risk-free opportunity for growers to try Rhizosorb as long as they purchase a minimum of 200 acres and still carry your traditional crop insurance against multi-peril. And if your yields do not meet 100% of your 10-year APH on that field where MAP and Rhizosorb were either split applied or stripped, you will receive a warranty payment of up to $40 an acre. Additionally, a lot of growers say, well, I'm willing to try something, but nobody ever pays me for my data. Well, we are also offering this opportunity for growers to provide us with your yield maps, win or lose. We just want the information back so we can continue to develop the story on improved phosphate efficiency through science and innovation. So from a sustainability impact and point of view, we've touched on many of the areas that are becoming global conversations. And since we are a sustainable phosphate production, our primary mission is to show these positive impacts. Rhizosorb is one of the currently only few fertilizers that actually have a life cycle analysis that has been done to showcase the positive effects of reduced phosphate in terms of the environmental situations that we are dealing with. 78% reduced runoff potential, leaching or off-site movement, a reduction by 84%, a decrease in eutrophication, and an improvement in, or a decrease in CO2 emissions. So what does that mean? Any of us that are farming in watershed areas or have tile drains where we're concerned not only about nitrates, but we're also concerned about phosphates, all the massive rain that we've had in certain areas of the country this summer has led to off-site movement of phosphate in some manner or fashion. And we have addressed this in terms of our sustainability impact. I'm going to mention this here. I'm not an expert in 45Z clean fuel, but this is a law passed by Congress that actually promotes and provides resources to growers who implement clean fuel production model in their production practices. Rhizosorb is one of those materials that can actually help you qualify for some of those units of credits. So I'd encourage you to talk to your ethanol producer, anybody in the Renewable Fuels Association, maybe talk to your local NRCS, and find out some more information about this, because this could potentially benefit you up to another $3.50 to maybe even $4 an acre based on that yield output. So if any of you are interested in talking further, here's a list of our sales team that is around the country. Our key accounts manager, Brian Milam, and I are in our booth over here. Feel free to stop by and talk to us and ask any questions that you have. And if we don't have the information, we can certainly get it to you. And anywhere else where you might be represented in the country, take that information down and we can certainly get in touch with you to provide you more information than we were able to go into today if you require it. But I'd encourage you to take a look at the new science and innovation of Rhizosorb for the coming future, because it's all about improved efficiency. We're looking for the top end yields, and we know we have limitations within our soils and in our production. So Phospholutions, Rhizosorb 839O, the next generation of phosphorus fertilizer going forward into the future. I don't know if we have any time for questions, but if you do, I can take some. If not, come by and see us at our booth. Thank you very much.